Subscribe and hit the bell icon so that you'll never miss a chemistry class.
Good morning everyone, and welcome to my channel. This is the second video on my channel. So today we'll be learning about laws of chemical combination, which is given by Lavoisier and Joseph L. Proust. So laws of chemical combination includes law of conservation of mass, law of constant proportions. So first we'll be learning about law of conservation of mass. So you know that law of conservation of mass means that mass can neither be created nor destroyed in a chemical reaction. So we'll take an example now. According to this law, during any physical or chemical change, the total mass of the products remains equal to the mass of the reactants. That means if you take mercuric oxide, it decomposes into mercury plus oxygen. If you take 100 grams of mercuric oxide, it decomposes into 92.6 grams of mercury and oxygen 7.4 grams. And if you add both this 92.6 grams plus 7.4 grams, you will be getting 100 grams. That means 100 grams on the left hand side and 100 grams on the right hand side. So that is law of conservation of mass. So now we'll be we'll be solving a question. So in this question it is given that if heating 10 grams of calcium carbonate CaCO3 produces 4.4 grams of CO2 and 5.6 grams of CaO. That means what? CaO plus CO2 gives rise to CO3. So if you heat 10 grams of CaCO3, it gives 4.4 grams of CO2 and 5.6 grams of CaO. That means what? 4.4 plus 5.6, 10 grams. It decomposes into total 10 grams left hand side and right hand side. So show that these observations are in agreement with the law of conservation of mass. Just now we studied what is law of conservation of mass. So mass of the reactants is 10 grams. The mass, what is the reactant here? Calcium carbonate is the reactant here. That is, the mass of the reactant is 10 grams. So mass of the products, which is decomposed into 4.4 grams of CO2 and 5.6 grams of CaO. That means 4.4 grams plus 5.6 grams, which gives again 10 grams. So hence mass of reactants is equals to mass of products. So here we can prove law of conservation of mass. So it is true. Now next one is law of constant proportions. See, law of constant proportions states that in a chemical substance, elements are always in a fixed proportion by mass. What is the meaning of that? We'll see that in the next point. So law of constant proportions was given by Proust in 1799. So what is substance here? Substance is a compound. That means in a chemical compound, elements are always in a fixed proportion by mass. That means H2O. If you take H2O, it is formed by 2 hydrogens and 1 oxygen. So what? Hydrogen is atomic weight is 1 and oxygen's atomic weight is 16. So 2H plus O. So 2 is to 16. Simplest ratio 1 is to 8. 2 ones and 2 eights. 1 is to 8. This is always the ratio for H2O. The simplest ratio is always 1 is to 8. If you can see the calculation here, atomic weight by the total weight. So 16 by 8, 2 8s and 2 9s. So it again gives 2 by 18 is also 1 by 9. Atomic weight by total weight. Atomic weight of hydrogen. This is atomic weight of oxygen. 16 is atomic weight of oxygen and 2 is atomic weight of hydrogen. So this gives 8 by 9, 1 by 9. 9 will cancel and it is 8 is to 1. It goes vice versa. So 1 is to 8 always. So next we'll be learning what is Dalton's atomic theory. So what is Dalton's atomic theory? John Dalton is a scientist. He provided the basic theory about the nature of matter. It is divisibility. The nature of matter is divisibility, which was just a philosophy at that time. But his theory was based on laws of chemical combination. So let us look at the postulates of Dalton's atomic theory. So he said that all matter is made up of very tiny particles called atoms. All matter is made up of very tiny particles called atoms is the first postulate. And the second postulate is atoms cannot be divided. Atoms cannot be divided. They can neither be created nor destroyed in a chemical reaction. And the third postulate, atoms of different elements have different masses and different chemical properties. That means, see, if you take element like calcium, it is an element. If you take element like gold, it is an element. but both of the elements, they have different masses and they have different chemical properties. One is reactive and another one is non-reactive. So that kind of thing is the third postulate. It explain that kind of things are explained by the third postulate. So atoms of different elements, they have obviously different masses. Mass will be different. One is 20 or one is some 50 like that. So mass will be different because the position in the periodic table is different. So masses will be different and also different chemical properties. So atoms of a given element are identical in mass and chemical properties. So for one element, whole of its atoms, they will be identical in mass and chemical properties. They have same chemical properties because all atoms should be identical. So they have same chemical properties, they have same identical mass. So that is the fourth postulate. Let us look at the fifth postulate. So atoms combine in the ratio of small whole numbers to form compounds. To form compounds, atoms, they combine in the small whole numbers. That is the fifth postulate. We'll look about that postulate now. So see, the relative number and kinds of atoms are constant in a given compound. So in postulate 6, you need to concentrate here. The relative number and kinds of atoms are constant in a given compound. So now what is relative number? Suppose if you take hydrogen peroxide H2O2, the relative number of hydrogen and oxygen atoms is H is to O. So it will be 1 is to 1. So that is the relative number. So the relative number and kinds of atoms are constant in a given compound. So 1 is to 1, it's constant. How many hydrogens are there? Those many oxygens are also there. So that is the relative number. In hydrogen peroxide, the relative number of hydrogen and oxygen atoms is 1 is to 1. Even if you take H2O, that will be that will be different. The relative number will be different. So there will be one relative number for each and every compound. There will be one different relative numbers will be there. So now we'll be looking at another question. So in this question, what they have asked is hydrogen and oxygen combine in the ratio of 1 is to 8. So the first sentence in the question they have given is that hydrogen and oxygen combine in the ratio of 1 is to 8. By mass to form water, you know H2, hydrogen and oxygen, they add up to form water. So they combined in the ratio of 1 is to 8, hydrogen 1, oxygen 8 to form water. So they're asking what mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas. So they're asking what mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas. So what is given in this question? Ratio of hydrogen and oxygen by mass to form water is given. It is 1 is to 8. So then mass of oxygen gas required to react completely with 1 gram of hydrogen gas is 8 grams. So the meaning of 1 is to 8 is that, so the mass of oxygen gas required to react completely with 1 gram of hydrogen gas is 8 grams. So this is the ratio of hydrogen is to oxygen. So the mass of oxygen gas required to react with 1 gram of hydrogen gas is 8 grams. To react with 1 gram of hydrogen gas, you need 8 grams of oxygen. So therefore, mass of oxygen gas required to react with 3 grams of hydrogen gas, it will be 8 grams into 3 grams, that is 24 grams. So mass of oxygen gas required to react with 3 grams of hydrogen gas is 24 grams, 8 into 3. So now we'll be again asking the question, what is an atom? So suppose if you take the example of a huge building. So what is the building block of this building? Obviously it's the small grain of sand with the small, there are like so many small grains of sand together form this building. So that is like smallest particle in that building is the smallest grain of the sand. So similarly, the building blocks of all matter are atoms. Same in this way, in this example, the building blocks of all matter are also atoms. So we'll be looking at how in the beginning these names of the elements are given. So in the beginning, the names of the elements were derived from the name of the place where they were found for the first time. Copper, Cu, cypress, gold, English word meaning yellow. So copper, the element symbol is Cu and it's from cypress. So many of the symbols are the first one or the 2 letter of the element's name in English. So many of the symbols are the first 1 or 2 letters of the element's name in English. So the first letter of a symbol is always written as a capital letter and the second letter is always written as a small letter. For example, if you look at copper, it is Cu and not C, capital C, capital U, it is capital C, small u. Aluminium, it is capital A, small l, and not capital A, capital L. Cobalt, capital C, small o, and not capital C, capital O. So symbols of some elements such as Fe is iron, Na is sodium, K is potassium are taken from names in Latin. You may get doubt, what is this Na? Then sodium should be Sd or something, and potassium should be Ps or something, and Fe, iron should be In or something. But no, these are the Latin names. Fe means in Latin it is ferrum, Na means it is natrium, K means calcium. So in the next class, so this much for the first class. Second class, in the next class, that is the third class, we'll be learning deeply about what is atomic mass and the other things. So please subscribe to my channel and hit the bell icon so that you'll never miss a chemistry class. And also, if you have any doubts, you can ask me in the comment section down below, and please subscribe to my channel. Thank you very much. Bye.